Okay, students, so today we are learning about application of cosine ratio. We did learn about the application of sine ratio in the previous lesson. So I'm going to tell you how it works. How we remember the formula of cosine is we have usually as in the previous lesson. You must remember it from the previous lessons. So ka toa. So stands for sine theta equals, O stands for opposite, and H stands for hypotenuse. Now C stands for cosine, A stands for adjacent, and H stands for hypotenuse. Now TOA is tangent. Tangent theta equals opposite over adjacent. So in the previous lesson, you have learned about the application of sine theta, how to use sine theta in finding either opposite or hypotenuse, or find a missing angle if opposite and hypotenuse is given. Today we will use and we'll learn how to apply cosine theta. But just a little review for how to determine the side lengths, like which one is opposite, which is hypotenuse, and which side is adjacent. As you should remember that these are primary trig ratios that we use, and it's applicable only in right triangles. So if you see a box like this in a triangle, it means it's a right triangle. This one angle is equal to 90 degrees. The two angles are less than 90 degrees, so they are acute angles. The side opposite to the 90 degrees is always the longer side, and it's called the hypotenuse. If we are finding this angle, then the side opposite to this angle will be the opposite side, and the remainder side is adjacent. Now I'll show it a different way as well. Let's say it's a right triangle. I inverted it. And if this angle is given, so this side will be the opposite side. This side will be the hypotenuse. And this side will be the adjacent. Okay, now you know how to use, how to name different side lengths in a right triangle. Now I'll teach you how to use cosine ratio. Okay. So if a triangle is given, a right triangle, this is a 90 degrees angle, and in cosine it is ka, adjacent and hypotenuse. So let's say if this angle is given and it is 35 degrees, and adjacent is given as 23 centimeters, and we are asked to find hypotenuse. Okay. So we can use cosine ratio in this case. So we'll say the formula is, as you know, it's cosine theta equals adjacent over hypotenuse. So cosine is a ratio, theta will be an angle. So theta will be replaced by 35 degrees. Adjacent, so this is the opposite side. This is the adjacent side. and this is the hypotenuse side. So adjacent is, we'll replace adjacent with 23 centimeters. That's the nice M. And hypotenuse is unknown, so I'll just use X. Now I want to cross multiply. So what I'm going to do is I'll just put 1 here, and it didn't change anything. You divide cosine 35 by 1, it doesn't change. It will just make it easier for us to cross multiply. So there will be no confusion. So okay, what we're going to do is we're going to multiply cosine 35 degrees and X. I'll write down X in the bracket because we have to find it. And I will times 1 times 23 centimeter, which will be 23 centimeter, okay? So if you multiply 23 by 1, it will just stay the same. We want to find N, we want to find X, and there is cosine 35 degrees multiplying with X. So what I'm going to do is I will, in order to get rid of it, we will do the opposite. So if it's multiplying, we're going to divide cosine 35 degrees, cosine 35 degrees, cancel, X equals like, so 23 centimeter divided by cosine 23. So I'll use the calculator. So make sure your calculator is in degrees mode. It should say, now mine one says GRAD, so it's gradient. So in order to change the degrees, I'll push on this DRG. Now it says DEG, so it's in degrees. If you can see, it should be in degrees. So I have to find the cosine 35 value first. So I'm going to push cosine and then 35. I'll get, so it is 0.81, 0.819, and let's say 2. Now I'll just divide 23 centimeters by 0.8192. So that was just an additional step. I could have just divided it. 0.8192, and our answer will be 28.07 centimeter. So you have to always write the unit, 28.06 centimeters. So this is how you can find a missing side length. So in this case, we were asked to find the hypotenuse and adjacent was given. Now, if adjacent is not given and hypotenuse is given, this is how we're going to do. We're going to do another example. And so this is our right triangle. Ooh, squiggly line. Okay, so 90 degrees angle. And this time I'll say, let's say this is my 45 degrees angle. So this will be the opposite side. And adjacent, we're trying to find adjacent. And hypotenuse is, let's say, 38 centimeter. And as you know, cosine theta is adjacent over hypotenuse, adjacent over hypotenuse. So cosine and theta is 45 degrees, adjacent is X, and hypotenuse is 38 centimeters. I will just put 1 there the way I did before. I will multiply X with 1. So X times 1 is X. It's not going to change anything. I will multiply cosine 45 degrees with 38 centimeters. Okay, let's see what cosine 45 is equal to. So cosine 45 is 0 decimal or 707. I'll say 1 times 38 centimeter. I want to times it with 38, and we will get 26.87 centimeter. You also have to pay attention to the answer. If the question is round your answer to the nearest unit, So it should be a whole number. So this one will be 27. If it says round to the 1 decimal place, then you have to round it to 1 decimal place. That will be 26.9. Now I'll also teach you how to find a missing angle using cosine ratio. Okay. So this is another right triangle. It's a 90 degrees angle. And let's say we are asked to find angle B. You're asked to find it. Then adjacent and hypotenuse should be given if you're asked to find cosine. So this is the opposite side. Let's say adjacent is 18 centimeter and hypotenuse is 29 centimeter. So again, we'll write down the formula, which is cosine theta equals adjacent over hypotenuse. Adjacent over hypotenuse, so cosine, we don't have theta, so we'll write the way it is because that's angle B. Adjacent is 18 centimeter. I'm going to divide by hypotenuse, which is 29 centimeters. So cosine theta is 18 divided by 29. I will get 0.62. And now in order to find the angle, what we're going to do is we will take the second inverse of cosine, so theta. You will say cosine, you get 1, second 2, and you will use the second function. So I'll say use second function and cosine. So you'll see the -1 on the top, punch in 0.62, and we'll get the angle. I will round it up to 52 degrees. So this is how you're going to use cosine ratio for finding a missing angle and missing side length that is adjacent or hypotenuse. Thank you.